All right, here we go. So recapping what we did last week. So we talked about completing the square, finding our magic number, substituting it in, and creating our perfect squares. What I'm going to go over with you is how to find the vertex form also, but not by completing the square, but using the vertex formula. Okay. So we're going to do the same problem, but we're doing it a different way. So we did it with completing the square. Now we're going to do it with the vertex formula. So vertex formula works like this. You have to find your vertex, and your vertex is negative b divided by 2a. Then what you get from that, you plug into the function to find your y value. And then that gives you your vertex. Okay. So when you're going through this, step one is to identify your a. So step one is find a. So for this problem, a is invisible. A equals what? 1, right? Do we all agree? A equals 1. Step 2 is to find the x of your vertex. So to find the x of your vertex, you're following this formula, negative b divided by 2a. So remember, this is your a, your b, and your c. So I'm going to plug in to find the x value of my vertex, which is going to equal negative 4 divided by 2 times 1, which equals negative 4 divided by 2, which is negative 2. Okay. Step 3 is to find the y value of your vertex. So to find the y value of your vertex, you're going to substitute what you got from step 2 into the equation. So to find your y value of your vertex, it equals f of negative 2, which means that wherever x is, I'm plugging in negative 2. So that gives me negative 2 squared plus 4 times negative 2 minus 1. That gives me 4 minus 8 minus 1, which equals negative 4 minus 1, which is negative 5. And the last step is to plug into vertex form. And vertex form is y equals a times x minus h squared plus k. We knew it was coming.
Wait, did y'all hear something?
No. Really, Greg? All right, we're gonna pause. All right, I'm not. All right, so we were on the last step was to plug in all your values. Okay, remember your h and your k are just the x and y values of your vertex, right? And so we already have our a, we have our h, our k. Can we plug it into vertex form? Yes. So we have y equals, and we have 1 x minus negative 2, which makes it a positive 2 squared, and our k is minus 5. Right here. Okay. So this would be the other way of going by doing it. Pay attention, guys. This would be the other way of going by doing it, minus being in what's that form called? Completing the square. Okay, so I'm going to go back and show you completing the square. So this is where we did it with completing the square. These steps that we follow, where we make sure we've identified our a variable. So we identified our a, we subtracted our constant, found our magic number, added it back to both sides, and then we made our side equal to 0, and then we're in vertex form. Notice that, did we not get the same result by following these 4 steps? Yes, we identified our a, found the x value of our vertex, which is our h, found the y value of our vertex, which is our k, and then we plugged them into the vertex form. Okay, so whichever way you choose or feel most comfortable with is the way that you should go by doing it. And the 1 doesn't matter because, well, 1 mattered, but it's Casper the friendly one. So he can appear and disappear. All right. Questions about either form? Okay. So, we're going to look at now completing the square, not, when your A does not equal 1. So when we look here, our A does not equal 1. So what do we do when A doesn't equal 1? So A does not equal 1. Well, when this happens, you have to multiply or divide. So we're going to multiply or divide to get rid of it. Okay. In the case of this problem, it is multiplied by half. So in order to get rid of it, we're going to multiply by 2, right? The reciprocal of a half. So we're going to multiply everything times 2. So when we multiply everything times 2, we're now going to be working with x squared minus 2x plus 4. Okay. But just because we multiply, it doesn't take away from the fact that our A still equal 1/2. Okay. Now that we've multiplied, our A is now equal to 1. We now just proceed with the rest of the steps. So step 2 was to move our constant. So step 2 is to move your C variable. So when we move C, how would I move C? I would subtract it, right? So we would be left with, we have x squared minus 2x equals -4. Step 3, we're going to find our magic number. So our magic number equals, anyone remember how to find the magic number? There we go. So it's our, and it's just our b divided by 2 squared. So if you're wondering what steps we're following these steps. So we're finding the magic number, and then we're at the part where it's b divided by 2 squared. Okay. Yes. We wrote it down last week. Okay. So we're on step 3 where we're finding our magic number. So b divided by 2 squared is where we're at. So our b in this case is -2. So we have -2 divided by 2 squared, which is just going to equal 1. Okay. Step 4 is you're going to add your magic number to both sides. Okay. And the reason why you have to do it to both sides, because what you do to one side, you have to do to the other, or will it stay balanced? Yeah. So we have x squared minus 2x, minus 2x plus 1 equals -4 plus 1. So notice I added the magic number to both sides. And that's going to simplify to, what's -4 plus 1? -3. If you owe me $4 and you give me $1, you now owe me $3. And then step 5 is after we add, then we're going to find our perfect square. So to find the perfect square, what multiplies to give me 1 but adds to give me -2? What multiplies to give me 1 but adds to give me -2? -1, right? A negative times a negative is a positive, and -1 plus -1 is -2. So we know that it's x minus 1 squared equals -3.
I like this.
Okay, and then last but not least is step 6 is just to set equal to 0. You want to set it equal to 0. Well, what I need to do to set this equal to 0? We need to add 3. So you're going to set equal to 0 and add your a back. And multiply by a. Okay, so when I add 3 and multiply by a, my results would be y equals, what was our a value? 1/2 times x minus 1 squared plus 3.
Did you, like, in the first step, did you multiply it by 2 to get rid of the?
To get rid of the half, yes.
Because you needed the.
You need your a to equal 1. Okay, if you do not like completing the square, could you use the vertex formula method as well? Doesn't matter which one you use. Nope, that's why I show you both, so you get to pick your own poison. Okay? Oh man, seriously.
They're really good.
I know a lot of really good shows I could be watching right now, but am I doing that? No, I'm not. Are you watching a show too?
Keeping up with the.
Okay. All right, so again, remembering vertex formula. So here's the vertex formula. It's just basically what it is. It's to make sure you can find the vertex given the equation, right? Without graphing, you should be able to find the vertex of a parabola by simply doing negative b divided by 2a, comma f minus b divided by 2a, and that's where you're going to find your vertex. Okay. So practicing the vertex formula, I would like for you to try the vertex form. So going over the vertex form, remember we've already modeled it once together, showing you the comparison between that and completing the square. So looking here, you have f of x equals 5x squared plus 20x minus 9. Please put in vertex form using the vertex formula. Okay, let's see what we did. So step 1 is to identify your a. And what's our a? 5. Step 1's easy. Step 2 is to find the x value of your vertex, which is your h value. And to find your h value, you're going to substitute in negative b divided by 2a. So I'm doing negative b divided by 2a, which equals negative 20 divided by 2 times 5, which gives me negative 20 divided by 10, which equals negative 2. Step 3 is to find the y value of your vertex, which is called your k. To find your k, you're going to substitute whatever you got in step 2 into the equation. So what do we get in step 2? Negative 2. So we're substituting negative 2 in. So that gives us 5 times negative 2 squared plus 20 times negative 2 minus 9. That's going to give us 5 times 4 is 20. 20 times negative 2 is negative 40 minus 9. I have negative 20 minus 9, which equals negative 29. No, you square exponents first. So then step 4 is you're going to plug it into vertex form, which is y equals a times x minus h squared plus k. Do I have everything I need to plug into vertex form? Yes. What is my a? 5. What is my h? And a negative times a negative is a positive. And then what is my k? Minus 29. And that's how you do it in vertex form. It only became a positive because my h was a negative. And so when I plug this into the formula, I have a negative times a negative makes a positive. All right, questions, comments, concerns? 4 steps. Just got to follow the 4 steps. Okay. Can't really make it any shorter. So that's all I got. Ha 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 ha. All right. Graphing. So being able to graph the quadratic. So we're going to go through how to graph a quadratic. Okay. Now, when you are graphing the quadratic, there are steps. So if you're in vertex form, you're going to find the axis of symmetry, find your x and y intercepts, decide if A is positive or negative, and then plot the points and connect. So these are the steps we go through for graphic. So if you look right here at example A, we're already in vertex form, right? So we're going to state the axis of symmetry. So in vertex form, your axis of symmetry is x equals your h value. So in this problem, it's a +1. So that means that our h is -1. That's our axis of symmetry. So I'm going to go to -1 and draw my invisible, imaginary, whatever you want to call it, my axis of symmetry. Okay, so that's my axis of symmetry. Oh, I skipped a step. Identify my vertex. Where's my vertex at? -1 and +2. So -1 and +2. So there's my vertex. So we got our vertex, our axis of symmetry. Then we're going to find x and y intercepts. To find your x and y intercepts, that means you're plugging in 0 for one or the other. Does that make sense? Okay. To find my x-intercept, I would be plugging in 0 for y. To find my y-intercept, I would be plugging in 0 for x. Cool? Okay, so to plug in 0, so when I substitute in 0 here, I have g of 0 equals -2 times 0 plus 1 squared plus 2. And that's going to give me 0. Because -2 plus 2 is 0. So that's my y-intercept, and so happens to also be in x-intercept. If you're at the origin, it counts as both, right? Counts as your x and your y. The beauty about quadratics is that they have to be symmetrical. So if I know a point on the right, then I know a point on the left. So my other point comes from here. You just need 3 points to make a quadratic. Do I have 3 points to make my quadratic? Yes. And then identifying your A. My A is negative, so my quadratic, that's the key that I did it correct. Is it going to be facing downward? It is. So I'm going to connect the points to the best of my ability. Pretend that I went through all of them. And there is my g of x. You want one? Can't have them all. Because I used them in my algebra class. Yeah. A teacher convention. All right, so we plot and connect. Now, notice here, this one right here is not in vertex form. And so since it's not in vertex form, we would either need to put it in vertex form or plug in the values to solve for. But the main thing here is we're going to find the vertex, okay? Your vertex tells you a lot. It tells you your axis of symmetry. It tells you where you're going, where you're starting. So if you look at, did I make a duplicate slide for that? Okay, good. So we're going to go through and look at this one. So we're going to find the vertex this time. It's not in vertex form, so we're going to have to do a little bit of math, right? So to find our vertex, remember that the h equals -b divided by 2a. So therefore, I have -2 times a negative divided by 2 times 1/2. A negative times a negative is a positive. And what is half of 2? 1. So we now know that our h is at 2. So we need our k. So to find our k, it equals h of 2. So we have 1/2, 2 squared minus 2 times 2. What's half of 4? 2. And minus 4 gives us -2. So now we have our h and our k. So our vertex is at 2, -2. Is someone at the door? Hello? What do you say? Oh.
Like right over here.
Okay, so that means our axis of symmetry is at x equals, shh, guys. Okay, Gregory is tutoring is not a substitute for not paying attention in class. Remember that. Okay, so we have x equals 2. So at 2, we have our axis of symmetry. And we also have our vertex, which is 2, -2. Now it says for us to find our x and our y. So to find our x and y, we're plugging in 0 for x and 0 for y. So when I plug in 0 for x, so if I do h of 0, that gives me 1/2 times 0 squared minus 2 times 0. And what's my y-intercept? 0, which makes sense because remember your c value is your y-intercept. And did I have a c value? No. So I know that my y-intercept is here. Conveniently, again, it's at the origin. So what do I just have to do? There you go. I just have to be equal distance to the axis of symmetry. So it's 2 units away on the left. So I'm going to be 2 units away on the right. Double checking our A. Is our A positive or negative? Positive. So does it make sense that we're doing this? Pretend that that's like the best parabola you've ever seen. Thank you, guys. Okay, and that is how you graph. So following the information and using the information you have to graph is very important. Yes. Huh? What time did we get out?
35.
3 minutes. Okay. Okay. All right. So lastly, we are, of course, for every unit, we have word problems. So we are here. A rancher is fencing a rectangular area for the cattle using the straight portion of the river as one side of the rectangle as shown in the figure. If the rancher has 1,800 feet of fence, find the dimensions of the rectangle that give the maximum area of the cattle. Okay. The key thing that why we know we're looking for a quadratic is because it wants us to find the maximum area. Okay. Typically, anytime you're looking for the maximum of a function without a given domain restriction, you're looking for where is the highest or the lowest if it's a minimum. Does that make sense? So here we know that we have fencing. We have W, L, N, W, obviously, right? And so I'm looking for the area of the rectangle of this area. Area equals 11 L times W. But the key thing here is I have 1,800 square feet, right, of fencing. So I know that 2W plus 1L has to equal 1,800. Does that make sense? Okay. And I know that to find the area equals length times width. So to create a formula for the area, I have to substitute in either for length or for width. Based on what we know, which one would be the easier to get by itself? The length. What would I need to do to get length by itself? Minus 2W. So now we have an area formula. Area equals, instead of L, we're substituting in 1,800 minus 2W times W. Yeah. So once we substitute, do you see how it naturally now became a quadratic? Because what would happen once I distribute that W? Anyone? It's going to make it into a square, right? Once I distribute that W, I now have 1,800 W minus 2W squared.
So wait, but that would be the answer, right?
No, we got to find the maximum area, which means that we need to find the vertex, your H and K. So we created our formula, and now we just got to solve for H and K. Solve for H and K. So for H and K, we need our A and our B. So this is our A, and this is our B. H equals negative B divided by 2A. So we have negative 1,800 divided by 2 times negative 2. Okay, so what's 1,800 divided by 4? What's half of 1,800? What's half of 900? 450. So we know that our width has to be, and our length, our width has to be what? 450. Does that make sense? So if our width is 450, then what would our length have to be? 900. So width is 400, therefore length equals 900. And we now found actual length. Okay. All right, that's our real world problem for here.